Let's study effectively with Miss ICT Skill Builder.
In this video, we're diving into the heart of your computer to explore how the processor acts as the brain to execute your every command. We'll also break down the critical roles of primary and secondary storage, showing you how your machine balances lightning-fast thinking with long-term memory to keep your digital world running.
Okay, so we all know computers are fast, right? But have you ever really stopped to think about what that actually means? We're about to pop the hood and take a look at the incredible speed of your computer's brain and the amazing team that makes it all possible.
But first, before we dive into the machine, let's start with a baseline. Let's start with you. I want you to honestly ask yourself, how fast can you think? I mean, how quickly can you really process something and come up with an answer? Take a look at these calculations on the screen. Nothing too wild, right? A little addition, some subtraction. Even if you grabbed a calculator, it would still take you a few moments to punch them in and get the answers. You got to see the problem, think about it, do the work. Just hold on to that feeling of it taking a few seconds. Now get ready for this. While you were just thinking about that first problem, a pretty standard computer could have done 1 billion calculations. Not in a minute, in a single second. Yeah, that's the insane speed we're talking about. So what in the world is the engine behind that kind of power? Well, it all comes down to one absolutely critical component, what we call the brain of the machine. Say hello to the Central Processing Unit, or as you've probably heard it called, the CPU. You can think of it as a tiny, unbelievably powerful calculator. It's packed with billions, literally billions, of microscopic switches called transistors that let it perform all those calculations at lightning speed. Okay, so to measure this crazy speed, we need a unit of measurement. Let's start with the absolute basic, 1 hertz. Imagine a clock ticking just once every second. That's a hertz. 1 action, or 1 calculation, per second. It's our starting block. But, 1 tick per second is ancient history. Today, we talk in gigahertz, or GHz. That giga prefix, it means a billion. So 1 gigahertz isn't 1 tick per second, it's 1 billion ticks, 1 billion calculations every single second. This is how we talk about modern speed. And this brings us to a term you've definitely seen thrown around, clock speed. It is exactly what it sounds like. It's the measure of how fast that internal clock inside the CPU is ticking away, telling us how many billions of calculations it can finish each second. So the main takeaway is this simple. When you see a computer with, say, a 3 gigahertz processor, you now know exactly what that means. It means its brain can perform 3 billion calculations every time a single second goes by. It's just a staggering amount of power. But there is a catch. A brain that works that fast can't be slowed down waiting for information. It needs an equally fast workspace, somewhere it can grab what it needs instantly. And this is where something called primary storage comes into play. And honestly, this is the perfect way to think about it. Primary storage is like a whiteboard right next to your desk. It's incredibly fast to jot down notes and read from it. But the second you unplug the power, poof, everything on it vanishes. It's wiped clean. The official technical term for this is volatile storage. Volatile just means it's temporary. The information is only there while the computer has power and actively needs it. It's built for pure speed, not for keeping things around forever. And the most famous example of this is random access memory, or RAM. This is the computer's whiteboard. When you open an app or a document, the CPU grabs the info it needs and slaps it onto the RAM for super quick, immediate access. So wait a minute. If RAM is a temporary whiteboard that gets erased, where do we keep all our stuff? Our files, our photos, our games. For that, we need something more like a library. So if RAM is the whiteboard, think of secondary storage as being like a stone tablet. The information you carve into it is permanent. It's not going anywhere when the power goes off. But as you can probably guess, carving and reading info off a stone tablet, well, that's a much slower process. And the official term here is persistent storage. It makes sense, right? The data persists, meaning it sticks around, even when there's no power. This is the permanent home for your operating system, your apps, and all your important files.
A perfect example in almost any modern computer is the solid-state drive, or SSD. This is your digital library. It holds huge amounts of data safely and permanently, just waiting to be called up when the CPU needs it.
So we've got the lightning-fast CPU, the temporary whiteboard of RAM, and the permanent library of the SSD. So why do we need both types of storage? Well, it's because to get that incredible speed we talked about, they all have to work together as a perfectly coordinated team.
Here's the heart of the issue. The CPU, our star player, is just way too fast for the library. Asking it to fetch data directly from the SSD for every one of its billion calculations per second would be like asking an Olympic sprinter to run to the public library between every single step. It would create this massive traffic jam. That's where RAM comes in. It's the coach on the sidelines, holding the exact data the CPU needs right now, ready to pass it over in an instant.
Let's just break it down real quick. Primary storage, like RAM, is extremely fast, but it's temporary or volatile, and it costs more for the amount of space you get. Secondary storage, like your SSD, is much slower, but it's permanent and way more affordable for storing tons of data. You really need both for a balanced, high-performance system. And this isn't just some abstract concept for big computers. This dynamic duo, the processor, the RAM, and the storage, is at the heart of nearly every single piece of tech you use. Your laptop, your desktop, your phone, even your smartwatch. They all rely on this same teamwork to run smoothly. So next time you tap an icon and an app just opens in a flash, you'll know it's because that high-speed team worked together perfectly. But when you see that little loading bar spinning, now you can ask yourself a question. Which part of the team is working to catch up? Is the data being pulled from the slow library to the fast workspace? It's a whole new way to see what's really happening inside the machine.
Thanks for watching. If this helped you clear up the concept, hit that like button and share it with a friend who might be struggling with it too. Let's build those skills together.